In this class, we're going to take a look at how you solve simultaneous equations, but slightly beyond the entry-level questions for this topic. So if you've not done any simultaneous equations at this point, maybe check out the class on that first and then come back in here, or just follow along here because the method is fairly similar. These are just a little more complicated and they've got a couple of extra steps of working in them. And then you could always check out the entry-level questions later, by which point they'll be easier for you anyway. But basically an overview, if this is new to you, is that simultaneous equations is where you've got multiple equations, usually two equations, certainly two equations at this level, but it could be more than two. Three equations is fairly common as well, but the number of variables matches the number of equations. So if you've got two variables, an x and a y, you need two equations. If you had an x, y, z, you would need three equations. That's just the way that it tends to work, or the way that it does work. You've got to have as many equations as you've got variables. We're only dealing with the cases where we've got two equations, and we need to solve them simultaneously, which means we need to find an x and a y value which satisfies both equations at the same time. So it's just like solving a normal equation in the sense that the value you get, the x value or the y value, whatever the letter may be, that value satisfies the equations. It's just that when we get our x and our y value, it satisfies that equation, and that combination of x, y satisfies that equation as well. So with these questions, they are going to be slightly more difficult than the entry-level ones, but following a fairly similar pattern, using the same technique, which is called elimination of a variable. So let's work through this example here. So I'm going to start by labeling my equations 1 and 2. If you watched the other class on this topic, the entry-level class, we did label them 1 and 2 there, but it wasn't that important to do so. This one, these types, it's more important to label them, and that's mainly because we're going to be creating new equations, either equation 3 or equation 3 and 4 in the case of this one over here. So just going through the kind of usual method for these, which is to kind of think of, well, definitely think of them as being in columns, and we're scanning along to see which of the variables coefficients are matched up. So a 3 and a 2, they're not matched up, they're different. A 2 and a -1, they're not matched up either. So that's unlike the scenario you see with the more basic form of these, where in the more basic form you will have numbers that are matched up for at least one of the columns. What we're going to do differently here though, we're going to force this equation to match up with the other one, or to get the variables to match up. And the way we're going to do that is just by multiplying equation 2 by 2, because if we multiply everything by 2, we're going to end up with a 2 here, and the 2 will match up with the 2 here. You could also get the x's to match up, but to do that you would need to multiply both equations. In this case here, we're going to have to multiply both equations. We'll deal with that in a moment. Remember that anytime you've got an equation, you're always allowed to multiply through the equation by some number. So if you had that as an equation, if you wanted to multiply through that equation by 2, that's fine, as long as you remember to multiply everything by 2. It's still the same equation. The answer for x, the solution, would still be the same. You're always allowed to do that, and that comes up in a whole bunch of question types where it's kind of beneficial to multiply or divide through an equation by a number. Gives you the same equation, just in different terms. So what we're going to do here is multiply equation 2 by 2. Try to keep your equations in pairs. So even though I'm not doing anything to equation 1, I'm just going to rewrite equation 1 like that. Equation 2 now becomes 4x minus 2y equals 6. A common mistake is to multiply the variable that you're interested in, but not the others. So remember to multiply everything by 2. Equation 1 has remained unchanged, so I'm going to keep calling that equation 1. Equation 2 is now modified into kind of a new version, so we'll call that equation 3 just to keep track. At this point we've got our y coefficients kind of matched up, they're both 2's. We want to eliminate those because we've got a plus and a minus. That means we're going to add them together. That's what's going to make them go to 0, so we're basically adding all of these columns. Okay, so 3x plus 4x gives us 7x. These guys eliminate to 0. There's no real need to put in the 0. 8 plus 6 gives us 14. So at this point we've now gotten over this kind of non-matched up hurdle, dealt with that, and now got to the point where we've got a simple kind of trivial linear equation. Dividing both sides by 7, and we're just going to get x equals 2. So that's our first solution. So at this point we want to substitute that back into one of our equations. We've got 3 equations now to choose. It doesn't matter which one you choose, you'll get the same solution anyway. Don't use one of your modified equations because the numbers are just going to be bigger because you've multiplied that equation. Go back to one of the original 2, they're going to be the easiest ones. I prefer to avoid negatives. Negatives tend to make things more difficult. Let's go for the first one. If you can't avoid negatives, then go for that. So 3 times 2, so 3x, x is 2, 3 times 2. This is actually going to, first of all, substitute x equal 2 into equation 1, just to keep track of our kind of what we're doing. So 3 times 2 gives you 6. Just writing down the rest of the equation, plus 2y equals 8. So you're going to get 2y equals 2 by moving the 6 to the other side. Solving that, you get y equals 1. So that's basically our solution pair there, x equals 2 and y equals 1. Okay, so hopefully that made sense. It is a little strange, this technique at first, so we're just moving on to the next example, just to kind of reinforce what we're doing here. So again, we'll start by labeling these equation 1 and equation 2. So scanning across this time, nothing's matched up. So we've got a 2 and a 3 and a 3 and a 2. And also it's more difficult because this case we could just multiply this guy by 2 and get these to match up. There's nothing you can multiply a 2 by to make a 3. Well, no whole number anyway. There's nothing you can multiply a 3 by to make a 2. So what we're going to have to do in this equation is in this question is multiply both equations. So the best way to do that is just choose one of your variables, either the x or the y. Let's go for the x this time, and multiply each equation by the opposite number. So the first equation we're going to multiply by 3, so it's going to be times 3. Second equation we're going to multiply by 2. If you multiply by the opposite number, then that guarantees that the two numbers will be the same. So multiplying this first equation by 3, remember to multiply everything by 3. So we're going to get 6x plus 9y equals 24. Multiplying the second equation by 2, 6x plus 4y equals 14. Because we've created 2 new equations, let's go ahead and label them with 2 new labels, so equations 3 and 4. And just thinking about how we're going to eliminate that variable. Well, this time the matched up variable is positive in the first equation and positive in the second, so we would need to subtract this time to get that to go to 0, which is basically what we're aiming for with the elimination. So that goes to 0. Then we've got 9y minus 4y giving us 5y, and we've got 24 minus 14 to give us 10. Now it's again just a simple trivial linear equation to solve. Dividing both sides by 5, we get y equals 2, and that's the first solution to our equation. So substituting that back into one of the earlier equations, so we're going to sub y equals 2 into, again, you could use any of the 4 equations, you'll get the same solution, but these guys just have higher numbers, don't they? You can see the numbers are a lot higher. Higher numbers just mean more chance of making a mistake, so best to avoid that. Better to focus on the easier ones. I'm going to go for equation 2 this time. Generally, the original 2 equations are fairly similar, so it doesn't massively matter which one you go for. So subbing y equals 2 into equation 2, so we're going to get 3x plus 2y, which is 2 times 2 now, which is 4, equals 7. Moving the 4 to the other side, and we're going to get 7 minus 4 is 3. Dividing both sides by 3, and we get x equals 1. So our solution kind of pair this time is y equals 2 and x equals 1. One thing just to note about simultaneous equations in general, whether it's the more difficult ones or the easier ones, these are actually the equations of straight lines. So if you've already done the straight line topic and you're familiar with the equation of a straight line, you'll know it's in the format y equals mx plus c. So for example, y equals, say, 2x plus 11, something like that. These guys are actually straight line equations which have been modified. So they're not in the perfect y equals mx plus c format, they're kind of manipulated in some way. So if you imagine that these guys are straight line equations, so let's say you've got straight line 1 and straight line 2. So let's call this straight line 1 and straight line 2, represented by equations 1 and 2. Then the only xy combination, if you imagine that xy are the points on the line, so this here would be the point 1, 2 with coordinates 1, 2. The only xy combination that satisfies both equations can be the point that lies on both lines, because you could have an xy combination that satisfies line 1 up there, but it's not on line 2. You could have one that satisfies line 2, so equation 2, but it's not on equation 1. The only one that satisfies both is the point of intersection. So sometimes these questions will be worded rather than here's two equations, solve them, it will say find the point where the lines intersect. And that really throws a lot of students off because there might not even be a diagram. It might just say something about lines and it's like, why is this even talking about lines? But just remember that when you're solving simultaneous equations, what you're actually finding is a point. You're actually finding a point 1, 2 in this case, point 2, 1 in this case, where these two lines meet. Sometimes equations are not asked, the questions are not asked in that way. Sometimes it is just, oh, here's two equations, solve them simultaneously. But just bear in mind that that is what you're actually doing in case you see a contextual question like that. For now though, I think focus less on that, focus more on learning this technique. It's not trivial, it takes a bit of practice. It's very easy to make a little numerical slip in here. If you do, then you can carry that through all of the working. So just be ultra careful with these. Like any topic, especially if it's new to you, gaining a bit of experience is really the key. So make sure that everything that I've explained there kind of makes sense. Hopefully it does. And then once it does make sense, try some of the practice questions and try a variety. Try ones that have got minuses and pluses, maybe negative numbers here. Just try and see as much variety as you can, because these are quite an important topic. They come up in quite a variety of courses that you might take in the future. So getting this idea of how to solve these down now can be quite a good investment for when you come to like a pre-calculus course or even a calculus course or just a bunch of other math courses you might take in the future. So yeah, check out some practice questions on these and just keep careful track of your working.